Hey guys, welcome back. You're still with me, Nkandu, and we're still looking at organic chemistry. And today's lesson is simple. We want us to look at nomenclature, meaning the standardized way of naming organic compounds. I've realized lately that looking at where we're going, we will meet a lot of organic compounds, and some of them they have been given traditional names, some of them have traditional names that are only known by a particular section of the society, meaning a particular section of the society might know a given compound in a different way, and going on that section of the society they also know it in a different way. So we're trying to find a way in which we name these organic compounds internationally using the UPAC method system of naming. And this lesson basically is just on the brief one. It's just looking at the basics. So time after time we'll still be going back and try to modify some of the ways of naming these compounds. But for a start, what I want to do is just to give the overview of what we need to observe as we name these organic compounds. But everything that we'll be doing will be based on the few facts that we are going to do in this lesson now. So we're simply saying we want to understand the UPAC. You want to understand the standardized way of naming organic compounds, and that's what we're calling the nomenclature. And this nomenclature was saying it takes into account two important things. So it takes into account two important things, that is the prefix and the suffix. So the prefix and the suffix is what is always is what is always considered, taken into account every time we're trying to name the organic compound. Now, what does that do these two words mean? The suffix, the prefix, basically I might not be good at the languages, but at least it's the first part of the word, and the word of my interest. Any word of my interest, I will explain this one using an example. If I can give an example of the word like this, called methane. This methane, I can cut it in two. It has, this should be E, not this. Okay, it's methane. So if I get this methane, if I get the first part of this word, the first part is the part that I'm calling the prefix, and this from here up to that far is what I'm calling the suffix. So the first part of the word of my interest, I call it this prefix, and the ending part I call it the suffix. So we're simply saying the nomenclature takes into account two things, the prefix and the suffix. And in this case we're saying the prefix is the first part of the word. So every word that you have of my interest, in this case I'm calling their names. So the first part of the words of those organic compounds, I'm calling it the prefix, and it means something in here, and the ending part, which I'm calling the suffix, also it means something here. As we advance, I think I'll introduce another thing that will be the root, but for the meantime I'll just focus on these two. So we're saying why are we saying we take into account these two things? The prefix, like I said, always comes at the beginning of the word. So the first part of the word, the first part of the name, I'm calling it the prefix. And why is it important that it is always taken into account every time we're trying to name organic compounds? So here we're saying the prefix is very much important because it tells us about how many carbon atoms are present in a particular compound. So when you have been given a molecule, we look at the prefix. What prefix is there? Then the type of the prefix will tell you and I the number of carbon atoms present. For example, I just gave the example here of methane. So the prefix is meth. Meth means 1 carbon atom. So meth equals to 1 carbon atom. And then I will move on to say eth. ETH mean 2 carbon atoms. And then I can continue and continue. So that's what I want us to observe. So I'm simply saying the prefix shows the number of carbon atoms in a compound that looks like this. Meth means 1 carbon atom. So every time you find a chemical compound having this sound, this, it means that particular section of that molecule there is only 1 carbon atom. And eth means 2 carbon atoms are present, and prop means 3 carbon atoms are present. But means 4 carbon atoms are present. Pent means 5 carbon atoms are present. I think you have heard of pentagon, a 5-sided polygon. X, it's now 6 carbon atoms present. So in a molecule, every time you have 8 carbon atoms, sorry, 7 carbon atoms, it's going to be called ept, meaning 7. Every time you have oct sound as the prefix, it simply means you have 8 carbon atoms in that particular molecule. And non, we're still saying it's 9, meaning there are 9 carbon atoms, and dec meaning there are 10 carbon atoms. So basically these are the prefix that you just have to know. You have no option but to know all these prefix. When you know them, it becomes easier for you as you advance in organic chemistry, because this carries this information. If you miss this, you miss this information, and if you miss this information, you can't write any organic compound formula. Okay, so let's now try to observe the last part of the name, the suffix. So the suffix, we're simply saying for this one, it gives us a very much important information again, because it tells me about the homologous series. It tells me about the family of the organic compound given. In which family is it coming from? In which homologous series is this particular organic compound coming from? So this is what this suffix gives. The suffix always tells you about the family. It always tells you about the homologous series. So observe the suffix. When you observe the suffix, then you understand where exactly is this organic compound coming from. When you understand this, then you will never fail to write any formula. Understand the suffix. So this time we're saying it tells me about the family. For example, we talked of homologous series, and we said those homologous series, we have homologous series that ends with A, N, E, E, N, E, Y, N, E, which one else? A, N, O, L, A, N, O, I, C, A, N, O A T E, that's N in ein ano anoic anoid. These at least these are alkanes, alkynes, alkanos, alkanoic acid, and the esters. So we're saying this suffix always tells me where the given organic compound is coming from. So for as long as in the name you see it ending with ane, then it should tell say it's coming from an alkane. For as long as it's ending with ene, then you should not say it's coming from alkenes. Yne, alkynes. ANOL, alcohols. Anoic acids. Anoid, esters. That's what we're saying. This tells us the ending part of the name gives us this information. Also very much vital as the prefix. The prefix will tell me how many carbon atoms are present, and this suffix will tell me about which homologous series am I getting this organic compound from. So here we have this we're saying the suffix, just like I've said here, this tells me to say whenever the name ends in ene, it simply means that they are coming from alkanes. ene meaning alkenes. Yne, alkynes. Ano, alkanos. Anoic acids, and anoid esters. So all these, they mean business when they are found in a given in the name of a given compound. So let's not ignore them. When you ignore them, that's poison. You fail to write, and it's not possible that you can master all of the alkanes. You cannot also memorize all the alkenes. You cannot also memorize all of these things, but at least you can observe the suffix, you can observe the prefix, then you can give their names. Just by you observing the ending part, you will be able to tell, to say, even if you have never heard of that, but you can easily say it is an alkane because of the way it ends. The way this ends is an alkene, the way that one ends is an alkyne, and that, and it goes on. So basically this is why I brought in this lesson, so that I help it someone out there. So I'll give an example here. If I get a compound with 2 carbon atom, now I'll get a prefix with 2 carbon atom, which we are calling eth. So if I get this prefix eth, if I join it with this one, is already ethane. If I do the same here, it will be ethene. If I do it the same here, it will be ethyne. If I do it the same here, I brought the same ETH down here and join it there, it will be ethanol. If I brought the same ETH down here, it will be ethanoic. If I brought the same ETH down there, it will be ethanoid. And that's what we're saying. So when you observe ethane, ethene, ethyne, ethanol, ethanoic, and ethanoid, it simply tells you to say all these compounds that I have here, they have 2 carbon atoms in them. That's why we are doing this now. If I brought in prop like that, prop, I brought in prop there. If I brought in prop and I remove that, okay, I brought in prop and I join it there with the, I join it here with this suffix. it will be propane. If I brought this down here, it will be propene, propine, propanoic acid, and propanoate. So basically, this prop means 3 carbon atoms. So whether you like it or not, just have to always know what these guys means. When you understand what they mean, the better you become, and the easier organic chemistry becomes for you. So I brought in this concept because we have a lot of traditional names that are only known by a section, a part of the society. For example, if you observe the acid that you experience in the venom of ants, when an ant bites me, there is a venom that is always left in me. That venom contains a particular acid, the acid that we call formic acid. Now, if I ask someone to say, write the formula for formic acid, can someone write? When I ask someone to say, write the formula for acetic acid, this is the acid that is always interacting with in the kitchen because it is found in vinegar. Can someone write? If I ask someone to say, write the acid, the formula for citric acid, can someone write? And this citric acid is the acid that we are always interacting with when we encounter lemon juice. But is it possible that this name, citric acid, acetic acid, formic acid, does it give us any information that you can write, use to write the formula? The answer is no. You can't write formic acid because formic acid does not give us any information. So no, that's the reason why we are coming to this lesson, so that we understand the standardized way of naming these organic compounds that is internationally accepted. Formic is a trivial name. Formic is the traditional name for methanoic acid. It is the acid that is found in the venom of ants. It is the acid that is found in vinegar, acetic acid. And this acetic acid is the acid that we know as ethanoic acid. Citric acid is the acid that we have in lemons juice. So this is the basis of my lesson. Please, as we advance, I'll continue trying to bring in some more concept on the naming aspect, but all I wanted is just to bring in the overall picture on what you should observe, because as we advance you might be finding these these names. They will use methane and it will not make sense. Why methane? So at least now we have an idea as we advance. Now I want to end this lesson with a quick review of the general molecular formulas of these amino acids that we have. I'm pretty sure I talked about them some time back, but for the sake of those who missed it, I just want us to observe it now. So, talking of general formulas, I was saying we have main general formulas. For alkanes, we have CnH2n plus 2. Alkenes, we have CnH2n. Alkynes, though I brought this one, like I said, I won't tackle it, but I brought this one for the sake of argument's sake of the multiple choice questions. It is CnH2n minus 2. Alcohols, we have CnH2n plus 1 OH. Remember, this is the functional group, so it should always be present. And carboxylic acid, we have CnH2n plus 1 COOH. This is a carboxylic group. It's a function group for acids, so it should always be present. And then we have esters. Ester is kind of complicated, but it's easy to get. CnH2n plus 1 COO, CM, H2M plus 1. So now I'll do one example for that, and I'll explain on that and that. So please stay tuned as I do that. Okay. So here we're saying, like I promised, I said I'll just do one for alkanes. So for alkanes, let's imagine we have one carbon atom, and we know the general formula is CN H2N plus 2. Okay, plus 2. So where there is N, this is the general formula for alkanes. So wherever there is N, I put in. N means the number of carbon atoms. So if I didn't mention this one earlier, N means the number of carbon atoms. So in every compound, if they tell to say this has one carbon atom, then you know to say for you to get the molecular formula, you have to substitute 1, which is the number of carbon atom, for N. So whenever there is N, you put 1 like that, and it will go where this is C1H2, and where there is N, like I said, you substitute it with 1, and there is a plus 2 here, and C1H 2 times 1 is 2, plus 2 I'll have 4. So here now I have C, and I have H, and I have 4 subscript there, and I'm pretty sure you have seen this kind of the formula. This is methane, and for you do the same, use the same general formula. You help yourself, try this one out. Start from carbon number 2, try to increase when carbon is 2, try to increase when carbon is 3, up to reach this, make this N to be 10, and see how which molecular formulas you might have here. That's the good way of practicing. Then, like I promised, I said I'll do one for alkanes, and now let me do one for organic acids. For alkenes, follow the same. For alkynes, just follow the same general formula. Everything that is there is still easy for you to get. Now, for organic acids, I've decided to do this one because it is somehow confusing. But alright, let me write it first. CN H2N plus 1 COOH. Now, before I start doing anything else, please get this straight. The number of carbon in an acid, the number of carbon atom in an acid, organic acid, this carbon in the functional group counts. This carbon also counts. So if you want, so in this case, it simply means that here we are starting with 1 only because there's no other carbon atom, but in here we're saying this carbon atom also counts. So if you want to write an acid with 1 carbon atom, if you had put if you ignore this one and you put 1 there and 1 there, automatically you get it wrong, because that molecule, that acid, you have 2 carbon atoms by the end of the day. So what we do is, how do I make that one to be 1? So for me to make the compound have 1 carbon atom, it simply means that I should start my numbers from 0, 1, 2, 3, and continue increasing. So if I want my number of my acid to have only 1 carbon atom, then I'll put a 0 there. So let me start with that. So when I put a 0, so it will be C0. Where there's N, I'll put a 0, and wherever there is N, like I said, I'll put a 0. So it's 2 times the 0 plus C 1 C O H. Anything multiplied by with this 0 is 0, and here it is 2 times 0, it is 0 plus C 1. So I only remain with the 1 hydrogen here, and then with the functional group looking like this, COOH. And this is how we write the first acid that we have as formic acid, the acid that we are calling methanoic acid. It has only one carbon atom, please. It has only one carbon atom. This is very much interesting. You don't need to stress on this one. So when you do this, then it's easy for us to move. So basically, if you want to make sure, if you want to write the formula for an organic acid which has 2 carbon atoms, remember there's already 1 carbon atom present. So you don't need to put a 2 there, put a 1, so that you not say there's already 1 and you put 1, so because there's another 1 carbon atom to count it to 2. If you want something to do with 3, then you put 2, so because you notice there's already 1, so it's like you are going -1. So please, that's how you keep trying and see how many formulas you're going to write. Maybe someone might ask to say, why this? Because here we just went straight, but here we said this carbon counts. So to make things easier for you, if you want to write methanoic acid, put a 0 there, because there's already 1. And methanoic, we said it has 1 carbon atom, and there's already 1 carbon atom. But how do I make it that come to pass? I need to get rid of that carbon, and this is how I did it. So keep practicing, and you will reach somewhere. Then there's another one that I said I would do. I promised to do another one. I said I will also tackle for esters. Now for esters, an ester is a compound that is produced when an organic acid and an organic alcohol reacts. When these two react, they join, and when they join, can I change the color? When they join, they produce water, and they give us an ester, 2N plus 1. Okay, so basically this is the general formula for esters. Quite confusing. Cn H2n plus 1 COOCm H2m plus 1. Now I will give you a key here. So I'll say when you have any, okay, the first part of the name, watch it, the first part of this molecule is coming from an acid part, and when I say the N, in this case we are looking at the number of carbon atoms in an acid. So the number of carbon atom in an acid. And the M, when you see the M, the ending, this end part starting from here, from that, this is an alcohol. So the M gives us the number of carbon atom, gives us the number of carbon atom of an alcohol that was present in an alcohol. So that's why we have this M and N. It's not here to confuse, it's the same, but just that I'm trying to find a better way of trying to differentiate the N's and the N from the M. So we have the acid part and we have the alcohol part. So, and this COO is the ester link. So this is the function group for esters. Now let's get moving. Let's say we have an alcohol with how many carbon atoms here? Which one should I do? Okay, let's say I have an alcohol with 1 carbon atom. When I do now, okay, the easiest one so that we balance the side. Let's say we have an alcohol with 2 carbon atoms. So I'll do 2 carbon atoms here, and I'll also do 2 carbon atoms here, so that to make sense, I'll balance with the 2 2's. So let N be 2 and M be 2. So when I substitute here, it's going to be, now for this acid, like I promised, the easiest one, I don't need to substitute it with a 2 because there's already, I wanted an acid with 2 carbon atom. So an acid with 2 carbon atom is basically called Methanoic Acid. And so what I'm going to say, I want to maintain 2 carbon atoms, but if I put 2 there, then this won't be 2 because this will be 2 plus that will be 3. So in this case, then I should put where there's N, I'm going to put 1, and then to be like that, and I'll go straight and multiply. Okay, let me just show it here, times 1 and plus C 1 C or I've now joined the alcohol part. I said when N is 2 and M is 2. So now for alcohols we go straight, where there's M I put 2, and wherever there is M I will just put 2 and compute the rest. Okay, so here C1 will come down like that, and 2 times 1 it's 2 plus 1 is 3, so I'll have CH 3 here, and C O now average there C 2 already, and meaning I'm here, and 2 times 2 it's 2 plus 1 it's sorry, 2 times 2 it's 4 plus 1 is 5, so I have 5 hydrogen atoms. So now I'll write it, this is an ester that were formed, and when naming an ester we start with the alcohol party, what type of alcohol was present. So the type of alcohol had 2 carbon atoms, which we are calling ethanol. So this ethanol, in this case we call it ethyl, and the type of an acid that was present is ethanoic acid, so it will be ethyl ethanoate. So ethyl ethanoate. So now this one is true, okay, but if you still meet something looking like this, it is also going to be like, sorry, like CH 3, meaning this carbon is bonded to 3 carbon atom, and this ester link like that, and this other carbon bonded to 2 hydrogen atoms like that, and the other carbon atom bonded to 3 hydrogen atom. This is 2 plus 3 is 2, taking us to 5. So in case you see it like that, it is true ethyl ethanoate. But at least let's hope you have learned something on how to use these general formulas. Please do a lot of practice. Ask questions if you have. Were not clear, ask. I've just like I said, alkanes, alkynes, there are no problems with alcohols. I was only interested in acids, just trying to show how we do that and how we get to this level of esters. Please, hopefully I've learned something today and it has been helpful. If it has, always share with friends and always remember to subscribe, and remember, COVID-19 is real. Stay safe. Till we meet next time. From me, I will say bye.